Hello, everyone. Welcome to the March 2012 Network Plus Study Group brought to you by Professor Messer. That is me, James Messer. And what we're going to do today is take the questions that you've sent me and try to answer them in the next hour or so. Sometimes we go a little shorter, sometimes we go a little longer. There were a lot of questions that came in this month, so I will imagine that we're going to be going through quite a bit to get this going. This is something we do every month. It's kind of nice to have this here. I like to be able to bring this study group just as something we do for free, some conversations that we have online. I have a chat room set up. We're going to be doing some interactive polls today that are going to be kind of fun. And it's something just to sit down and have fun with. And what's nice about this is you give me the content. This is where your questions come to me all throughout the month. We do one every month. If you want to find out when we do these so that you can participate live, simply go to professormesser.com/calendar and you can see when the next A+ study group is, the next Network Plus study group, and if we do anything else that's live, you'll see the times. Usually I do these on a Saturday at 1 o'clock Eastern time. I'm never quite exactly sure if that's always going to work out that way, so just keep checking the calendar and you will know for sure. And of course, a lot of this ability to do this absolutely free study group comes from your support, not only of you watching the videos on our website. Thank you very much for that. We love you coming and watching those videos. Some of you also grab these videos and take them with you for later. You can purchase those if you go to professormesser.com/download-net plus. Before we get involved with too many Q&As that are here, let's talk a little bit about what has happened with Network Plus recently. You may have seen in December a new version of Network Plus certification came out. It was the N10005. The N10004 was the previous version. So you may hear me referring to these in the study group as we go through this, the 004, the 005. I'm trying to get all my content in these study groups really focused towards the 005, but there really wasn't much difference between the two. About 75%, 80% of the content was exactly the same. We have a previous study group where we went through all of these pieces. And if you go to the top page of our our Network Plus certification video list, it's at the top of freenetworkplus.com. If you spell all of that out, networkplus.com, freenetworkplus.com. At the top, there's a link there that says, what's the difference between 004 and 005? And I go right to the video and the right section of that study group where you can listen to what those differences are. There are some significant changes. There are things that were absolutely new and added. So make sure you have a look at that. If you've been studying the 004 and you may be thinking of taking the 005, you're going to need to learn some of that new content. And we'll talk more about that later on in the study group of which one you should be taking and why you might want to take one over the other. We'll go through those pieces. If you already have a Network Plus certification and you're acquiring these ongoing certification units, these education units, then you can get one of those for just watching this study group. And the units there, I've got the link there on the screen. You can go to the CompTIA website and you can see exactly what you have to do to be able to document this particular study group. You can see you need a description of the activity, the content covered, time and date, location, and proof of completion. But we don't have a proof of completion. You just say, yes, I attended, and that should cover that 1 hour in there. So if you are doing these continuing education units, make sure you take advantage of this just by watching and keeping things up to date with your Network Plus certification. Well, we're obviously going to go through your questions. We're going to go through everything you've sent me, or at least a huge part of what you sent me. I have hundreds and hundreds of questions that came in. So sometimes it's a little difficult to go through every single one in an hour, but a lot of them are the same questions. So I was able to group them together to go through these pieces. One of the questions that I ran across first is this one, which is pirates, ninjas, robots, aliens, or zombies? CK asked this, and I thought, well, that's a good question. Would it be pirates, ninjas, robots, aliens, or zombies? It's a really good question. Well, I'm not the only one who should be answering this, and this is the part where you're going to get involved with what we're going to do on the study group. And what I would like to do is make sure if you've got a browser open, pop open a new window or pop open a new screen. If you've got your phone next to you or your Twitter client next to you, if you go out, let me get rid of this my screen here so you can actually see what's going on in this particular view. So if you text a code, one of these codes, to 37607, you can see the codes that are associated with each answer. You will see it there. You can also send a tweet to @poll with the code that corresponds to pirates, ninjas, robots, aliens, or zombies. Or very simply, and probably the easiest one, is to simply go to pollev.com/messer and you will be able to see that. And we're already seeing results are coming in. You can see we've got 4 results. Let me flip over and we can see what those results are as they're coming through. We can see robots is in the lead right now. This is something we're going to do throughout this study group. So as you are going through and watching, I'm going to have some questions for you. I'm going to have some QA that we can do. I'll be asking for your input about a lot of things. So make sure you have your client ready. Go out to the website at polev.com/Messer. And you may just want to keep it there because you'll simply refresh that when we get to a new question so you can answer the next question that's coming through, or have your Twitter client or whatever you're using to be able to send that in. I'm sorry that if you're outside the United States, that SMS is not going to work. Apologize for that, but Twitter will and the website certainly will. So you can use either one of those. So far, 15 results, and robots has taken a commanding lead on here. So you can see 38% of the 16 results we have clearly robot people, and Ninjas is making a run at it here. I'm surprised Ninjas is only at 12%. We should really take all these statistics and break them down, probably do some cross tabulations later about this. So this is a good test to be able to see, is this something we're able to do? Look, zombies suddenly jumping to match the robots. I'm going to sit here for a moment. I was going to move to the next slide, but now I'm engrossed. Now I'm engaged as to what's there. So it's neck and neck, so to speak, with the zombies, or head and head from the zombies and the robot side. Quite a bit going on. Well, let's not worry so much about the pirates and the ninjas and the robots and the aliens and the zombies. Let's maybe do a real question of some of the things. So now that you understand the process of going through and doing some of these polls, I have a real question for you. This one happens to be about what you've done with Network Plus. So I want to know, how long have you been studying for the Network Plus exam? And you can then, up here, you can see the codes associated with those. It's 1 to 3 months, 3 to 6 months, 6 to 9 months, 9 to 12 months, and more than 12 months. So this is a pretty important one for me to know because I build these study groups with the ideas of who's watching. And we've done about 6 months of these so far. So it would be interesting to see as these results are coming in. And let me bring up the interactive screen so we can see that. So 80% of you that are participating that have answered so far of these 22 results, 1 to 3 months. So we've really got a large group of people, 12% or so, 3 to 6 months, about 6 to 9, about the same number in that time frame. And 9 to 12, more than 12 kind of goes down from there. So this is good, though, because now you're going to see content today that even if it was some that we happened to briefly talk about in an earlier study group 6 months ago, we're going to go through some of the others and try to drill into different aspects of some of those questions on here. I don't want to repeat anything from my previous study groups, but I want to look at different perspectives of what's there. So clearly, 65% of you that have answered so far have been studying for about 1 to 3 months. That's good. I think the content that I've created for this really focuses on someone who's just getting into understanding this information. And some of these things I go into at a very high level, some things I go into at a very detailed level. So I'll mix this up a little bit just because you've been studying for more than 12 months. I think you'll still get something out of what we're doing today. I certainly hope that's the case anyway. So let's now move ahead with some of these things that we've got. Our questions. So we're going to go through a series of questions that we have about the A+ certification and the content of what's on some of these questions that we have here. Our first question, since there was a lot of people asking about fiber, and more fiber on the Facebook page, and I got a number of questions about fiber on my questions that were submitted this month prior to this, and I've hundreds that came through this month of the questions. And I thought this was one that I saw a number of people asking over and over. What is really the difference between multimode and single mode fiber optic cables? Now I'm going to go through technically what the difference is, and then let's talk also a little bit about, are you using these differently? Do you even use them differently in a data center? How do they feel? Do they look different? What are the situations? When would I know when I should use one or the other? Let's kind of go through all of those pieces. Now with fiber optics, there are so many different measurements. There's so many different specifications. There are many different ways of transmitting this light over these fiber optic connections. And we put them really into two categories, although there are some others on the outliers. We call multimode fiber and single mode fiber. And for the purposes of your Network Plus, those are the two categories that you need to know about. Multimode fiber is one that communicates as the light is going in, and really is designed to go really 2 kilometers or less. And depending on the standard that you're using and depending on the equipment that you have, it may be much less than 2 kilometers. It may be half a kilometer. But this is really what we consider to be the short range type of fiber. If you are inside a single data center, you are probably connecting up all of your switches and all of your routers, or perhaps within the same building. You're probably using multimode fiber to do this. And as you can see by the picture, this multimode fiber is one that when light goes in, it might bounce a little bit differently down the fiber as it's going. And light goes in one way and bounces around. Another set of photons going in may bounce another way. They go through multiple modes to get to the other side. Therefore, they are a multi-mode fiber. That's where the name comes from. What's nice about the multi-mode fiber is it's relatively inexpensive. It's using a light source like an LED. Effectively, it's just a flashlight, just shining it in there and sending it off to the other side. It's obviously a very powerful LED, but it is one that doesn't require a lot of complicated pieces to be able to send the signal from one side to the other. So that means the price of connecting devices via a multi-mode fiber connection are certainly less expensive, and the fiber itself is less expensive. So that's nice too. When you're connecting a bunch of devices in a data center, you want your cost to be as low as possible. Multimode fiber is the lowest cost way to connect devices together using fiber type connectivity. Obviously, copper is even less expensive. Copper is really inexpensive when you compare it to fiber. But if you've got to put fiber in, and there are a number of reasons why you would do that, this is definitely a easy way, a very simple way to do it, and a very low cost way if you have to deal with fiber. So the question from Steve in the chat room, does making it multi-mode, single mode have to do with the type of fiber you're using, wire or fiber you're using, or the type of method to send the light? And it's actually both. If you looked at a single mode fiber, it's like this. There's a single mode of light going through. It doesn't bounce around a lot. This fiber that you're using is designed on single mode for long range. You can go quite literally in some standards up to 100 kilometers before you ever have to reprocess this data to regenerate the signal and send it another 100 kilometers. So this is a huge distance. You can go across the city on a single mode fiber and have just 2 pieces of equipment on either end of the connection, and those can communicate back and forth. Some cases over very high speed gigabit type connections. Obviously, you're using a very powerful light for this. In many cases, it's a laser. So laser beams. So you want to be very careful about putting your eye anywhere near these ports. You don't want to check your fiber to see if the light's coming through by sticking it up and looking at it. That's not a good idea. It probably won't hurt you very much over a very, very extended period because the strength of that light decreases over time, but you don't want to do this in a data center. It's just a bad idea. Just bad math. Do not look at the laser beam coming through there. It makes perfect sense. So let's go back to Steve's question then. If you've got these 2 types, you're going to have equipment on both sides that's going to connect these together. The equipment is going to say this is a single mode connection or this is a multi-mode connection. And in some cases, if you look at some of our other Network Plus videos, it's these modular type connections. The manufacturer of the networking switch or the router will give you a blade that you slide into the chassis, and then there's just a gap there, and you're expected to take a separate module. Let's see if I have one. I think I have one in my here somewhere. Here's a good example. This is one that we talk about. It's a GBIC. Let me plug my headphone back in that I disconnected while I looked in here. So I've got this module, kind of hard to see here. Let me bring my camera back up. This is a GBIC. This is a gigabit interface that it's a module that you plug into. There's the end of it that plugs into the switch. And on the other side is where you plug in the fiber. So what's nice about this is this happens to be, if I look at it with my eyes, this is a short wavelength, it says. So this is a single or a multi-mode short wavelength, a multi-mode type of GBIC. This interface then can be easily slid right into a switch. I slide in another multi-mode on the other side that matches. You can't go single to multi, you got to go multi to multi. And now I can plug in a multi-mode fiber to connect those together. So everything has to match. You have to have multi-mode connections on one end, and they may be hardwired or they may be modular like this. This is a GBIC, GBIC, a gigabit interface. I forget the exact gigabits interface connection, something like that. It's the modular name. It's one of those things where it has a name and none of us use the name. It's GBIC. This type of connection is an LC connection, I believe, looking at it. This is one where once you have these now, people who work with this stuff usually have them sitting in a pile somewhere, and you're ready to plug things in. If you're inside the building, we'll plug in a couple of these multi-modes. We'll find our multi-mode fiber. We'll plug it in. Got some fiber patches. We'll stick it in there. Or they may say, we need to go to the building on the other side of the campus. This multi-mode is not going to make that. We can even pop this module out, find a single mode module, pop it in, put a single mode in the other end, and connect underneath the building. We'll have somebody take that connection and go all the way to the other side and plug that into the other side. We may contract with someone to put the fiber in the ground. And so it goes all the way to the other building. And now we've got strands of fiber in the ground we can use for whatever we like. So if we look at these and start looking at how we're using this fiber technology, it's got a lot of flexibility. And whether you're using multi-mode or single mode, you can really decide which one works for you. Now in the chat room, somebody was saying, what are we going to do with when we put this in and connect it all up together? We talked about the interfaces. What about the fiber itself? Steve asked that earlier. The fibers look almost exactly the same. You're right. This was an LC connection. And somebody asked, what does the LC stand for? There's there's an entire video I have on the different fiber connection types. And there's different names. We call it LC, and Lucent Connector, because that was the company that came up with that name, is probably the more common, but there are other names that we have for them as well. And the connection type doesn't matter. I could have one connection type on this side and a different connection type on the other. As long as the fiber in between is the right kind of fiber, I'm okay. The thing you have to think about when you're pulling these fibers out is what they are. If you looked at side by side a single mode fiber and a multi-mode fiber and just looked at them, they look almost similar. We tend to have single mode fiber a different color. Usually it's a bright yellow, and a multi-mode fiber is usually an orange, but it doesn't have to really be that way. They could be colored different things as well. Sometimes you can look at the end of the fiber itself and try to discern what the type of diameter is of the fiber. That might help you figure out what it is, but even that isn't a guarantee. So most of the time, your fiber written on the side of it, stamped on it, when it went through the process of creating it, on the outside of the fiber connection, it is actually written and stamped in ink what it happens to be. And they put those every meter, every 3 feet or so. So you're able to see those things. So that's one thing when you start working with fiber, it's really just like working with copper. You plug in the connection, it works. Just with copper, we know it's RJ45 and you're done, and it's category 5 or category 6 and you're finished. With fiber, there's a few extra things to check. Is it single mode? Is it multi-mode? And if you're designing a network or you're putting a piece of equipment in and somebody says, yeah, we're going to need to plug that into a fiber connection, your question should be, was that multi-mode or is it single mode? And they should, oh, it's inside the building, it's multi-mode. Okay, I'll make sure that I have some multi-mode fiber patches, and I'll make sure that we have the interfaces, the GBICs, or we have the other type of modular connections that we want to be able to use to slide into our equipment and be able to use that fiber. So it's an important thing to remember also. It comes up quite a bit on your Network Plus exam. Not only do you need to know the difference between multi-mode fiber and single-mode fiber, but you also have to know what type of standards of networking will use this fiber. What would I expect to see in 100 megabit? What type of fiber connection is that? For a gigabit, what type of fiber connection is that? What is the distance I can go with that? Each one has different distances with it as well. So that's another thing to think about when you're working with those. If you start doing a lot with fiber, it just becomes second nature. So one of the questions, this actually, Steve says, this is a silly question. It's actually not a silly question at all. Can you bend fiber or will the glass inside break? So it's an important consideration. The fiber that's inside of this is a glass type of optic, but it's not glass. So you can actually bend it. You could wrap it into a knot and pull it, and you won't break the inside of the fiber. Now, one of the problems you have, though, with fiber, optic fiber is you really can't have too much of a bend radius on it. Although you're not breaking it, you would never implement it that way. You want that fiber to be as straight as possible. And if it curves, you want it to be a very soft curve going around, because the fiber, as it's curving around, the light kind of hits the end of it and it bounces or it stops. So you don't want a lot of bouncing inside of your fiber. You want to be as simple as a connection as possible. And you can wrap them into, and if you go into data center, you'll see wrapped into circles and put in there, but you don't want it to be a very tight bend radius, we call it. Be very easy to do that. Dave asked, what was the name of the device the fiber cable goes into? You could be plugging into a hardwired fiber connection, or you could be plugging into a modular connection in that particular device. I have another video that goes through the many different modular type connections you could see on those pieces. And it's one where you do run into many different connectivity types. Right after you ask whether it's single mode or multi-mode, ask what type of connector you need, because you never are quite sure exactly the type of connection. Is it one of the fiber RJ connections? Is it an LC connection? Is it an SC connection? There's so many different fiber connections. So there are videos that I have just for all of those different connection types. So you'll be able to see those as well and see exactly which ones you're going to be working with. So there's fiber. We've got, in the chat room, someone makes the point that multimode fiber can be used with LC connector. Multimode fiber can be used with any kind of connector. Single mode fiber can be used with any kind of connector. So you can't just look at the connector on the end and go, oh, that's multimode or single mode. It could be anything. You're never quite certain. You're going to have to look at the side of the fiber and see what's stamped on it to know exactly what's inside of that. And that's why I've run into this situation where we have gone in to do an implementation. It's 2 a.m. We have 1 hour of downtime. We go to plug in our fiber. It's the wrong connectors. We have a connection in our router that is an LC connection, and I've got MTRJ. That's not going to work. So we end up either having to find the right connections or reschedule for the following week. There's another question in the chat room. Do I have a media converter to show fiber to Ethernet? One of the recent videos I just completed for the 005 that is online at freenetworkplus.com is a media converter video that goes through a lot of different types of media converters so that you can see how you would go from single mode to multi-mode, how you would go from copper to multi-mode, and see all of those pieces in between as well. So there's fiber. Boy, we talked a lot about fiber on this one, more than I was expecting. You guys in the chat room are awesome coming up with some of these questions. Another question I get a lot, and I don't mean a little, I mean a lot, is the OSI layers. Now, you have to remember, and I'm going to talk about this at the end of this study group, the number of times you're expected to answer questions about the OSI model are pretty small when you look at all of the different things you have to know for the Network Plus exam. So one of my tips for everybody is don't get so fixated on a particular topic that you start spending hours and hours and hours and hours trying to get it down. You want to spend a little bit of time, certainly. You need to understand the basics of the OSI model. It's something you'll run into all the time. But do not worry that you don't know every single thing about it. You may not even get a question on your exam about the OSI model because it is one part of one domain across an entire test. So don't get all wrapped around the axle, as we say, with that piece. In the chat room, C.W. Bolton is using my exact mnemonic to remember this, which is all people seem to need data processing, application presentation, session layer, transport layer, network, data link, and physical. APSTNDP. All people seem to need data processing. All people seem to need daily prayer. Please do not throw sausage pizza away. Please do not touch Susan's pet alligator. You guys are awesome. Please do not touch Susan's pet alligator. Of course. How could I not have remembered that? That makes perfect sense. Let's go through each one of these layers, though. What do these even mean? What do these even correlate back to? So let's try to take a layer and stick it into something in the real world. Let's see if we can do that. So one of the things at layer 1, this physical layer, which really is talking about signal, but in our world, our human being world, we also think about this as being something that is physical and real. So a hub, for instance, a cable, a NIC, a network interface card. Layer 2, you're now moving up into the MAC address area of things. Layer 3, our network layer, deals with the network address. That's why we often call the IP address the network address. Back when we used to have IPX from Novell, we had IP, which we would use for other things that came from many different organizations, IP being a standard there. We even had other things like Banyan Vines. We had Apple Talk. We had a lot of other protocols. There at one time we were running 3 or 4 protocols on people's computers. These days it's really IP. We don't really do much more of that. But at the time we'd say, what is the network address? And we're talking about the IP network address, the IPX network address, the Banyan Vines network address, and being able to do that. Once we move up above that, we're talking about port numbers at the transport layer. TCP and UDP and session and presentation are really talking about encryption and controlling and tunneling protocols. And finally, at the top, of course, is the application layer, what we think of as the application itself. Now, the OSI model is something that is not cut in stone. This isn't a place where you can put something absolutely in a certain layer. In fact, certain protocols and certain methods kind of slide between layers sometimes. This is just a model to be able. And a good example of that in the chat room, Gagandius asks, is the LAN card or the network interface card working in both physical and data link? Well, in some cases, it sort of does. That's a good example of the MAC address is at the layer 2. The physical signal is layer 1. Certainly, your interface card is working at both of those layers. That's a really good example of how things blend together to be able to do some of those pieces. If we were to take a packet capture, and I really recommend you do this, if you are studying for your Network Plus certification, absolutely go look at a packet capture, download Wireshark, load it on your machine, capture some packets, even if you have no idea what you're looking at. Do it. Just capture some packets, go in there and just gather what you can see going by. Because the result, once you stop the capture and you look at one single frame in the decode, you start to see really interesting information about what's there. If I was to drill down, notice at the very bottom part of this frame 88 that's here, where 192.168.0.8 is talking to 72.14.247.19. It's talking to it over an encrypted link. Now you can see, and this is frame 88, which is 2005 bytes on the wire. And that's really my layer 1. It's on the wire. That's the signal on the wire. Layer 2 are these MAC addresses right here. It's an Ethernet 2 frame. The source MAC address is this Dell device. The destination MAC address is my router, which is this Netgear device. Let me get rid of my big head so you can actually see this on the screen. There we go. If I look at the next layer up, layer 3 is the internet protocol, the IP address, 192.168.0.8. My destination is Google Mail at 72.14.247.19. Now, layer 4, transmission control protocol, TCP. Here's my port numbers. 18.429 is my source, and 443 is my destination. And what is 443? All of you out there, goes over TCP port 443? It's right here. HTTPS. There it is. So we know this is a port that is commonly used for encrypted HTTP traffic. And there's sequence numbers and acknowledgement numbers and length numbers in there as well. And then everything above that is layers 5, 6, and 7. Sometimes we tend to lump together 5, 6, and 7 into just one set of things. In actuality, they are doing different things, but in this particular case, secure socket layer is there, and above that, we know there's an application. In this case, it was Google Mail. So it's a very common way to step through some of these pieces of just looking at a single frame to understand where things are happening at what OSI layer to be able to understand that. And if we were to follow that conversation all the way back up, you would see this layer 1 with our wires, layer 2 with our MAC address, layer 3 with our IP address, layer 4 with our port numbers, 5 and 6 are here for your session and your presentation, your encryption. And then finally, the application in our particular case was Gmail. So there's a lot going on if you start looking at this, but the OSI model, we call it a model, so it's something that we as human beings can follow. But if you look at a simple packet capture, you can see this model, it really lays things out quite nicely because we can really see them delineated completely within those protocol decodes. Now let's go through some of the questions we got in the chat room during that time. So why do we even use this? CW Bolton says, we got this OSI model. I got to memorize it. It's not real. It's a theory. What in the world are we having to memorize this stuff for? primarily we memorize it because it helps us communicate to other people when we are troubleshooting a problem where we think the problem might be occurring. If you see a problem with routing, you're seeing an IP address that's not getting to the other side, and somebody says, well, I think your problem is your switch. You could say, well, my problem actually tends to be up here at the IP address layer. I'm pinging out there to that IP address. I'm not getting a response. I've looked at my switch. My MAC addresses are in the right place. My MAC addresses are at layer 2 are working exactly as I would expect. My forwarding table looks proper. But if I look at my routing table at layer 3, I can see the problem is there. And then people can take their efforts of, well, let's take the switch out of the equation then. Let's focus on layer 3. Let's focus on the router to see what's going on. It really does help you understand where things are happening in the big scope of things when you start understanding how flows of traffic go back and forth. And especially if you move into security, you move into doing things that are very, very detailed networking, this is going to help you understand even better how these processes occur when an ARP happens, when somebody's doing encryption, when you're sending information and configuring routing tables, when you're trying to manage things with spanning tree protocols. Each one of those is at a different OSI layer. And you're going to have to focus on understanding exactly how those are supposed to work. So it's an absolutely valid question that C.W. Bolton asked, which is, this seems like it's crazy. Why should I be doing this? There's actually some very, very valuable information that's there. Another question is the TCP/IP model is which is used nowadays for the internet is based on the OSI model. It absolutely is. And for your Network Plus, you absolutely need to know it. There's an entire video just on the TCP/IP model. In reality, in the day-to-day working world of networking, we still tend to use the OSI model a lot more when we are working at a network level because the TCP/IP model only has 4 layers. It's really focused on the IP protocol, and it doesn't talk a lot about MAC addresses. It doesn't deal a lot with things happening over the wire. It's not the real emphasis of the IP model, but it is a very useful model for understanding how TCP/IP operates. That's a little bit outside the scope of what we're doing for this particular one, but it's something that we can have here that you have to know for your Network Plus certification. So don't miss that one. Don't focus only on the OSI model. You also have to know the TCP/IP model. Fortunately, that's the only TCP/IP or the OSI. Those are the only 2 models that you're going to have to know. So the question from Steve is, TCP resides on layer 4 of the OSI model. Does it mean that TCP/IP model is a submodel within the OSI? Not really. You really can't stick the IP model and stick it into the OSI model. They really are focusing on different things. There are similarities. There are some overlap there, but it's not a one-to-one. So don't even think of it as a subset of OSI. Try to look at it as its own model, and you'll do much better for understanding what you need to know for your exam information. So that's the OSI model. There's a lot more on the videos that I have, a lot more information about OSI. Remember, don't obsess over it. Don't spend days trying to figure this out. Use it as another thing you need to know, and you'll be surprised when you finally get through your entire Network Plus studies and you go back to OSI, things will start fitting together a little more because at that time you've learned about switches, you've learned about routers, you've learned about other pieces, and it certainly helps when you finally get to that point. Let's do another poll, shall we? Let's see what this poll is. I even forget what I put in here, so let's see what pops up. It'll be fun for me too. This poll is, what layer of the OSI model does FTP and SMTP run on? So that's a pretty good question since we just finished talking about that particular piece of it. Now we have a little music for your polling process. You can, of course, if you've just joined us, you can go out to text a code, this code for physical application network and transport. I see I only gave you 4 choices. You can send that to 37607. You can tweet to add poll with the code that makes sense, or the easiest way, I think, is to go to pollev.com/Messer and put in the answer there. Trying to understand what part of the OSI model do those 2 run on. Now, if we think about the whole model from end to end, We're talking about the all people seem to need data processing, application, presentation, session, and all the way down again. Now we're looking at, this is certainly not wiring signal on the wire. If we step through these, it's physical. Nobody chose physical. None of you were thrown by that. This is not signal on the wire. FTP is not signal on the wire. That's FTP. It's file transfer. SMTP is mail transferring. So definitely not physical. You weren't thrown by network either. These are not IP addresses. So the network layer really didn't fit into this either. So we've got these two things. We got transport, which would be port number level communication. And we got application that would be effectively application layer communication. Now, if I said, what OSI model does TCP port 20 and 21 run on? Now that question would be very specific to a port number, which means the transport layer would be applicable. That makes perfect sense for what we're doing with the transport layer. But since we were talking about the actual FTP application that you see on your screen. We're talking about the SMTP application that's transferring mail between one site and another, and is transferring it using wires, and is transferring it using IP addresses, and is transferring it using port numbers, but we're talking about the application. Therefore, the answer for this one is the application layer. And so 71% of you, right on the money. Steve is calling shenanigans in the chat room. Trick question. Wasn't that tricky? Well, it was sort of tricky. I'll give you a little bit, but that's exactly the type of question you will get on Network Plus exam. They're going to ask you a question about the app. Because if you think about it, all layers, it uses all layers of the OSI model, doesn't it? Well, of course it does, but we're asking very specifically about FTP and about SMTP. So I'll give you that. It's one where you really have to think it through and understand what's being asked. And in that particular case, it does make sense. So I can absolutely understand where you're coming from, Steve. Let's shift a little bit then and talk some about IP addressing. One of the biggest questions I tend to get is about doing IP addressing. And the question that came through, this is from Thomas, that said, how do Class D and E addresses relate to IP addressing? We often hear about Class A, we hear about Class B, we hear about Class C. What about D and E? We never hear about Class D and E, do we? So where would we use a Class D address? Where would we use a Class E address? And I thought that's a pretty good question. It's one that doesn't come up very often, but it also means that we should go back and think about how we use these addresses. And let's talk about first these classes. Now, classful subnetting, where we do this was something that was created very early on with IP addressing. We didn't used to have subnet masks. Didn't need them. There were only so many devices in the world, and we determined what mask you got based on what the IP address of your device was. If your IP address of your device started with 11 dot, then that was a Class A address. If your IP address started with 165.245, that was a Class B address, and we gave it that particular subnet. So it's very easy to see exactly the type of subnet that you would expect to see. We didn't have to do a lot of calculations. In fact, you only had Class A, B, and C. There was D and E as well, but Class A, B, and C was it. You didn't even have a choice over what subnet mask you chose. It was decided for you. So yes, there were subnet masks, but you didn't get to decide what they were. They were predefined, if you will. We have not used classful subnets since 1993. This is important because people ask me, hey, wait a second, I see on your network you're using a 10 dot address, but you're using it with a Class C subnet mask. That's wrong. That's a Class A address. You use a Class A subnet mask. If this was prior to 1993, that might have been the case. Not necessarily the case even back then, but early on that was the case. Not anymore. Now we have very, very different. We have classless subnetting these days that can use any number of bits. And I go into details about that when we start talking about those pieces in here. So, but we still use the terms. If I'm typing in an IP address, I'm in somebody's network 192.168.1.7, and I ask, what's the subnet mask? And they go, oh, it's Class C. Okay, I know exactly what you're saying. Now, it's not really Class C. What they're really saying is that mask is 255.255.255.0, that, by the way, is very similar to what we used to use. It's exactly the same mask as what we used to use when we had classful subnetting, and that one happened to be a Class C. But instead of saying 255.255.255.0, we say, oh, it's Class C. much faster to say it's just Class C. So we still use the terms day to day. It's not really something that's automated. We use a different kind of subnetting, and I have the classless-based subnetting videos that we can watch separately to this. We're not going to go into too many of those today, but very much different in the way we do things today because we don't have a need for class. In fact, we don't want class-based subnetting because it's too limiting. For instance, if you have a Class A address, which meant that the leading bits of the address started with a 0, which means your class was the number, the first number in your IP address was between 1 and 126. That means that you can have 128 networks with over 16 million hosts per network, and that's the default subnet mask. Okay, if you got a 10 dot network, all right, you need to start building out some hosts. You need some 16 million hosts. Start buying some computers. Let's go. If you were assigned a Class A subnet back then, you are wasting a lot of hosts because there's no way you had 16.7 million hosts in your network. And of course, you only had 128 networks to throw them around. So maybe if you needed more than 128 networks, what were you to do? Well, you just wasted a lot of space. So that didn't work very well. That's why we went to a classless base. Now, Class B was 128 to 191. There were 16,384 possible networks with 65,534 possible hosts per network. Very useful to have that. And of course, those leading bits of 110 and then anything, which if you looked at it in decimal meant that the IP address was somewhere between 192 and 223 as that first octet, meant that you could have over 2 million networks, but you could only fit 254 hosts per network. And you're right in the chat room, Steve is right on the money. Even 65,000 sounds like a lot of computers on one network. You're absolutely right, Steve. Completely impractical. Nobody uses that many. That is not something that is normally seen. But if you've got the ability to create 16,000 networks from a Class B network, well, maybe you're fine just wasting thousands and thousands of possible nodes on that network because you can build out 16,000 networks in your environment with over 65,000. You'll never reach 65,000 hosts per network, but boy, I got a lot of room now to build out networks. That's why we see quite a bit of Class A, Class B subnetting a lot of places and Class C still, because you've got 2 million possible networks. And most people think I'm never going to put 250, even 254 hosts on a network is a lot actually. So a lot of people think Class C works for me. I'll use that. And I'll use those private addresses that came out after all these subnets were created. We created private networks. We created the 10 dot networks, the 172.16s, the 192.168s. Very, very common. In fact, in railways in India, as Gagandius, I hope I'm saying that anywhere close to being right, they're using 172.16. They're using those private addresses, and they're subnetting probably as even a Class B to subnet it that way. You could even subnet it Class C. Very, very common to see that. It's one of those things where when you start breaking it out, you can start to see there's huge limitations. You're making these huge jumps between hosts per network. You're making these huge jumps between the number of networks available. That's why these days we have classless-based networks that we would design. So we wouldn't use just 8 bits or 16 bits or 24. We'd use some in the middle. And of course, that's why it's so complicated when you start doing your subnet calculations. Now let's go to the question though, Class D and Class E. Class D networks, you can see, start with 1110, which means their first IP addresses are going to be between 224 and 239. And notice everything on here says not defined. There's not really numbers of networks. There's not really hosts per network. We don't use that range of IP addresses for subnetting networks. We use that range of addresses if we're going to send traffic over multicast. And multicast, if you go back and look at this video from multicast, is one where you send out one packet, and that packet automatically goes and splits itself up and copies itself out so that many people can see that one packet. You have devices on your network that are designed for multicast that will take that one packet and spit them out to multiple places simultaneously. So this is different, for instance, than what we're doing right here. For those of you watching me on Ustream, Ustream is sending out a separate video stream for every single person that is watching. And right now I've got 101 people in the chat room. 101 possible streams are going out to all of you that are watching this. So all of those are going out. That is 101. If I build out and have another 100 people join, that's 100 more streams. So you can see we're using up a lot of bandwidth. Every time we add another person, it's adding in more and more and more bandwidth, With multicast, if we were all in a multicast system, your software that you're using on your browser would subscribe to the stream. Ustream would send out one packet, and all of the networking infrastructure devices on your network would know to send out and copy those packets to just the people that needed it. And you're still sending out, ultimately getting down to you. You're still using the same amount of bandwidth, but coming from me at Ustream, I'm sending out a single packet. Very, very efficient in the way that it operates. We use these subnets or these IP addresses that start with 224 to 239 to define those Class D multicast networks. And Class E, we just don't use at all. You can see those ranges 1111 are between 240 and 254. We say reserved, which means we just don't use them. There's not enough bits there to do anything with, even if we wanted to use them for something. So they're just not defined in the class-based world. Now, in the real world, where we're using classless subnetting, we use things that are at the higher level. We can use those IP addresses if we wanted to, but many of our infrastructure devices won't route 240 to 254. They are reserved. You shouldn't use them. They're not for use anywhere, and really nobody does use them. They're just a section of the standard class-based subnetting that we never used because the mathematics weren't really going to allow us to use those and do anything useful with them. So we decided in the standard, don't even use them. Use your Class A, use your Class B, use your Class C, and if you're doing multicast, use some Class D addresses, and you're done. So that's where the Class D and the E came from. And in the chat room, we were talking earlier about these number of hosts on a network in this class-based system. So somebody said, if I remember right, it's best practice not to put more than 500 hosts on a broadcast network, and it's probably even functionally much smaller than that. It depends, really. If your devices on your network don't send a lot of broadcasts, you can fit a lot more devices on a single network, on a single broadcast domain. If all of your devices use broadcast to do different things, and you put 10 stations on, now they're all broadcasting. Now you put 100 stations, they're now all broadcasting. You put 250 stations, it gets crazy. You're using so much bandwidth and time on your network just to send broadcasts, which isn't very effective either. In practical use, we generally have much fewer than 100 devices on a single broadcast domain, on a single VLAN, on a single network, to be able just to keep things manageable. Now, it doesn't mean you couldn't put 500. You can absolutely put 500. Just be expecting that there's going to be a bit of overhead for broadcasts going across that particular subnet. So it's just something to keep in mind. It's one of those things that is engineering. You have to think about what makes sense for what you're engineering on your network. So one of the questions from Ryan is the multicast only relevant within the local area network or within the internet or outside over the WAN or outside of your organization? Multicast is easiest to manage when it's inside of your local network, but you can absolutely use multicast on an internet-wide basis. A very common multicast application is stock ticker information and stock selling details. There are the stock exchanges are sending out ticker information to the brokerages. The brokerages are receiving a multicast stream. The stock market's just sending out a single multicast with, here's the stock price for Microsoft. Here's the stock price for Apple. Here's somebody that would like to buy some Microsoft stock. Here's someone who would like to sell some Apple stock. And they send that multicast out to all of the brokerages. So effectively, they've all got the same opportunity now to receive that multicast in. And then if they can quickly buy or sell and get their order in first, then they're going to get that particular commission. That's exactly the way it works. They are very, very, very focused on speed and efficiency of networking, and multicast is the very common protocol that's used to do that. Let's see if we're looking at this. And the quote in the message in the chat room: when you have so many devices doing all these broadcasting, separate them into VLANs, make them smaller. You can always break up your networks into smaller pieces, add other types of IP addresses into that. Very common to see that piece. Okay, let's remove my head from the picture again because I have another question coming up. This question, get ready for your what port number is commonly used for SNMP? Text to 37607 the code that you think is the right answer. You can also tweet at poll with the code that you think is the right answer, or just go to pollev.com/Messer and just answer it there. You don't have to know any of those codes if you go to the website. What port number is commonly used for SNMP? We have UDP 161, we have TCP 110, we have UDP 53, and we have TCP 143. So we got a lot that we can do with that piece. Now you've got to think about this. This is one of those that's really, we got to memorize our port numbers for this piece. UDP 161, TCP 110, UDP 53, and TCP 143. So you might want to think first, is SNMP, TCP, or UDP? You have to think about that piece. And you got to think at that point, what number is it? So pick a side and pick a number. Did anybody remember what SNMP really is? It's a really good question to start off with. It is the Simple Network Management Protocol. So that might help a little bit. So we got 23 results in. Let's see what we've got so far with the results. We can see, oh, wow, it's almost evenly distributed. UDP 161 is 30%, TCP 110, 26%. We've got 53 and 143. Now you can, of course, still keep putting these results in there. You don't have to stop at this point. So SNMP, network management, Simple Network Management Protocol. Absolutely correct. So when we look at Simple Network Management Protocol, one of the things that you'll run into is different methods. Now, don't confuse SNMP with SMTP. There's one where SMTP is mail, so that Simple Mail Transfer Protocol. We don't want to confuse that with SNMP. And SNMP is one where UDP 53, that's used for DNS. So we know that's not going to be the right one. TCP 143, anybody know what that is offhand? I think that's IMAP. So if you're doing mail, that is the IMAP protocol. TCP 110, I kind of threw in another mail there. I was trying to trip you up with the mail piece. I think that's POP3, I believe, and that's TCP 110. So that leaves us UDP 161 is what is commonly used for Simple Network Management Protocol. So yeah, you got to think about that when you're going through your exam. Make sure you stop. Make sure you think about what they're asking you. Make sure they ask you a question that has something like this in here that is an acronym. You may want to go ahead and write it out. They're going to give you a whiteboard. They're going to give you a piece of paper or something to write on. You may want to write that out just to make sure you're reading that properly. If you're going too fast, you think, it's SMTP, and then you go to the next one. So that's one of the certain circumstances where you're going to want to make sure you know what you are reading. Now, in reality, I don't believe I put the SMTP port number on here. That would have been really tricky. I probably should have, just to trip you up, but I didn't. So I wanted you to at least have the differences between those. But I would bet if you got a real exam that was using those acronyms, they would try to trip you up, I bet. And CW Bolt makes the point, if you memorize your port numbers, you're done. You know every single one of them cold. And if you're asked those on the exam, you'll have it right there to be able to do that. Okay, that was a pretty good one, I think. We are got another question that came in. And we're talking a little bit about port numbers. We were talking a little bit about security. We have this question. This question is, how does a firewall and a DMZ help protect the network? Which one is the most important? And Arish asks this one. And you see this all the time when people are designing networks. They're trying to put together what the network is going to be. They're designing out the security. And for your Network Plus exam, you are asked about firewalling and you are asked about DMZ. So both of these things are going to be important considerations for you to know. And the question about which one is the most important, neither one of them is more important than the other. They perform and have two very different functions on the network. So we want to look at both and understand how are those two used. We want to get a feel for what's happening with those. So let's look at that. So if we break this down, I made a little picture, drew a little picture. This is not a fantastic picture, but for what we're doing, I think it speaks. So out here is the internet where everybody is going. And we've got a firewall right in the middle. And so everybody in every organization right on the edge of their network, we call it, the edge as it's going out to the internet, has a firewall. Firewall's right there. Now on the firewall, on the inside, there are often many ports on that firewall. Sometimes there are 2 ports, sometimes there's 3 ports, sometimes there are 24 ports available for you to use. It just depends on the type of firewall that you're using. What most people will do is build out 2 separate interfaces. Sometimes these are called zones inside of firewalls. And they'll call one the trusted interface or the trusted zone. And that's where you put your stations. That's where you put your workstation, your printers, your network-based devices. All of those go on the trusted side of the network. Then you also will build out something called a DMZ, a demilitarized zone. And as the name implies, this is not exactly the safest place to be, but it's safer than most because in a demilitarized zone, you generally have somebody with some guns, with some armory that is watching the zone. And if bad things come in, it takes them out. And that's your firewall that's doing that for you. Now, the reason you separate these things out looks like functionally, I mean, they're just two ports off of a firewall. They look like they're exactly the same in what they're doing. So why do you separate them out? Well, that's because inside of your firewall, you are now going to create security policies. And these security policies determine what traffic goes where. And it's very, very common to say in your firewall to have a security policy that says if a flow of traffic is originating on the internet and it is coming into my firewall and the destination of that flow is to my trusted network, drop it. I'm not going to allow anything from the internet to go to my trusted network, period. I might have a policy that says if you're on my trusted network, you can go surf YouTube, you can go surf Facebook. That's a flow going the other direction. You would absolutely have a policy that says if you're coming in from the internet, you can't get to the trusted network ever. That is one of those lines in the sand. That is a stake in the ground. That is something you would never, ever, ever want to change to be able to do that. That's because you want to keep all of your users safe. You don't want anybody to have that level of access. But you probably, in your organization, you probably have a web server. You probably have file transfer servers. You probably have mail servers. You do have to have people on the outside of your network, on the internet, go into the DMZ so that they can provide you with email, so they can provide you and access your web server, so they can do the things that you normally need to do to get your business done. The DMZ is also going to have security policies, but they're going to be very tight. They're going to be very, very small policies that say, if you're coming in from the internet, you may communicate with my mail server, but only to this IP address, which happens to be my mail server, and you may only send the port number associated with mail. And on the latest firewalls, you can even say only allow mail traffic. You cannot send any other kind of traffic inside of that. So it's a very tight policy, but it's obviously allowing traffic to initiate on the internet from one mail server and communicate over to another mail server that's in your DMZ. So that's the big difference between these two, is a little bit of access to the DMZ, zero access to the trusted network. That's why you keep them separated. Now, this also means that if somebody was to access your web server, and let's say we're allowing web traffic to it, but they happen to run across a vulnerability that's inside of Microsoft IIS or inside of Apache or inside of some other service running on that device, and they're able to exploit that device, take advantage of that vulnerability, and gain administrator access or root access to that device, they now could possibly jump somewhere else on the network. Well, because the DMZ is this self-contained entity, the only place they would be able to go is the DMZ, because we also in our firewall have a rule that says the DMZ may not communicate to trusted. Nobody gets to communicate to trusted. Just the trusted can talk out, nobody can talk in. So that means if somebody did get loose in the DMZ, it's still a bad gig, it's still a bad thing. You don't want that to happen. But one of the advantages is at least now you're limiting the coverage. You're limiting where those people are able to go. So that's why on your firewall, you would build out a DMZ and you would build out other zones, is exactly for that. Now, in practical use, most people have many different zones they might use. They might have a server farm zone. They might have a wireless network zone. They might have a guest network zone. They might have a trusted or internal zone. They might have many, many other zones. And they would build rules inside of their firewall that will allow or disallow access to those zones from other zones. So it's a very common way to allow or disallow access and to greatly limit the scope of what might happen in those particular zones. Now, some of the questions in the chat room, Dave asks, we've got firewalls up here. Can I touch a bit on HA pairs, high availability pairs, and how they work? I think it's a little bit outside the scope of the Network Plus, but what it effectively is I drew a picture of one firewall here. What happens if the power supply in that firewall fails? You can see nothing happens. The internet goes away for all of your users. Your web servers go away for all of your clients. You never want that to happen. In reality, you're really building out probably multiple firewalls here. And in most cases, people have a firewall that runs in what we call this high availability mode. One firewall is always on, it is active. And usually you have another firewall that's sitting there not passing traffic called the passive firewall, and they're constantly talking to each other. Hey, I'm the passive firewall. Hey, Mr. Active Firewall, are you still there? Active Firewall replies, yes, I'm here. Passive Firewall waits a little bit and says, okay, how about now? Active Firewall says, yes, I'm still here. Now, if something happens on that active firewall, it loses a power supply, the passive firewall says, hey, are you there? Didn't hear anything. Hey, are you there? What happened to you? Wow, you're not there anymore. Let me take over. The passive firewall turns himself, makes him the active, and now he's now the active firewall. That all happens in milliseconds, and nobody knows anything happened, and now your flow of traffic continues to go, even though something happened to your original firewall. There's also situations where you would have both firewalls active at the same time, what we call an active-active HA. It's a lot more complicated to have to figure out where the traffic goes, but it's a very common way to do that. I would say the vast majority of people are running an active-passive configuration to be able to do that. Let's see if there are any other questions in the chat room. Honeypots, some people talking about honeypots. Honeypots are a little bit different. Honeypots are where you would create a machine that looks like it's something that has some juicy stuff inside of it, has honey inside of it. Maybe you stick it on your DMZ and you wait for the bad guy to get inside of it. And usually it's a device that is designed to let people in if they try to bang on the door a little bit and watch what the bad guys try to do with it. There's no real data inside of it. There's no access to other devices. In fact, some honeypots look like multiple devices all at one time. Virtualization allows us to do a lot with it. That's very interesting to be able to have that focus on what's going on inside of those honeypots. And you can watch what the bad guys are doing and understand what they're going after and see what vulnerabilities they're trying to take advantage of so that you can be prepared when they try to actually hit one of your real machines. Very, very useful. So Gloria asks, can you program on the firewall to catch someone who jumps from the DMZ? Absolutely. In fact, usually you put very tight controls on what traffic goes out of the DMZ, because if somebody on the inside of your network is trying to do something, they're in the trusted zone and they're trying to talk out to the internet, and you've created a policy that says you may not do that. If it's an IT administrator, they might go to your web server and bounce out from there because your rules are different in your firewall. So you generally have very tight rules, not only on the inbound of your DMZ, but also on the outbound of your DMZ as well. So very, very useful to be able to see that. Now, if we have on the network, we were talking about, Gloria was talking about catching people doing that. And there's also one of those that has trying to stop bad traffic. You'll see as you're part of your Network Plus certification, understanding IDS and IPS technologies as well. So it's another side of it. Maybe we'll save that for the next study group. Now I'm at the top of the hour now. I have a lot more content to go through. I told you I'm going to be here for an hour. It looks like we're going to go well over an hour. I apologize for those of you that have set aside an hour, but I will have the replay of this available for you to watch afterwards. We're going to keep going. I got a lot more to go through, though. So we're going to sit through that piece. Some other good questions coming in. Rob in the chat room says, what's the difference between a DMZ and a proxy server or a service? Those are really three very different things. A DMZ is what we just designed here. Sometimes we will build out inside of our network. We'll put an extra server just before people go to the internet that will be a proxy server. Everybody has to talk to the proxy server directly, and then the proxy server goes out to the internet. So effectively, it sticks a guy right in the middle that breaks up the conversation so that no user is directly communicating to a web server or any other type of service out on the internet. Everybody talks to the proxy server, and the server proxies that communication out and then sends the answer back to the end user. Some people feel that that is a more secure environment. There are advantages and disadvantages, obviously, and we've got other videos on our network, our Security Plus certification, that go into the details of proxy servers and how they are used as well. I think it's time for another poll. Let's have a look at what the next question is, since I can never seem to remember what I put here. What does a switch use to make its forwarding decision? And I think I may have even given this away earlier on in the study group. But if you text to 37607 the answer of IP address, MAC address, port number, or access control list with the numbers that you see there, you can also tweet it to @poll and send the right code, or the one that obviously I think is easily, go to pollev.com/messer to be able to see what you think a switch uses to make its forwarding decision. These questions in the polls are coming directly from you. You are sending me these. And it's nice to be able to have those, because what you've done is ask the question on here, and I'm simply turning it into a poll so we all get to figure out exactly the way this would work. What does switch use to make its forwarding decision? IP address, MAC address, a port number, or an access control list? It's quite the question, isn't it? Let's see what most people are saying. Most people saying 67%, none of you were fooled here. MAC address is really what's used. IP address would be used if we were trying to make a forwarding decision in a router. A router works at that OSI layer 3 IP address layer. A switch works at OSI layer 2, the MAC address layer. A port number is layer 4. Generally, we think of port number access being done by a firewall. What port number gets to go where? These days, firewalls work from port numbers all the way up to application layers and IP addresses as well. Access control list, that also would probably go into the realm of a firewall as well. So the question that Rob asked in the chat room is, what about a layer 3 switch? What the heck is a layer 3 switch? Layer 3 switch is a bad name, really. There are switches and there are routers. Switches work at layer 2, routers work at layer 3. A layer 3 switch is a marketing term that was used to describe turning on routing functions within a switch. It's a very bad term because there is no such thing as a layer 3 switch. A layer 3 switch is a router. That's what that is. It's a bad way to describe a router, isn't it? So whenever you hear the term layer 3 switch, that's a router. Even though it says layer 3 switch, the marketing term says layer 3 switch. The spec sheet says it's a layer 3 switch. The user interface describes the layer 3 switch. That's a router. It's always, always, always a router. It's a bad way to start combining terms and confuse the rest of the world, isn't it? It is a router. So whenever you see that term layer 3 switch, it's usually someone that has or a piece of equipment, a switch that has the ability to turn on routing functions within the switch so that you can have separate VLANs and you can route between VLANs. But it's effectively the same thing as putting a router right next to the switch and routing everything through that router independently. It's just saying you've got a router inside of it. I don't know anywhere in the CompTIA certification, Tom, that calls it a layer 3 switch, but it's useful to know because you'll see it written even today, a layer 3 switch. It's not a layer 3 switch. It's a router. Always think of it as a router. It is not a switch, not a switch, not a switch. So we will go through those other pieces too. So another question that comes up quite often with this, what's NAT? What is this? It's kind of hard to figure this one out, isn't it? Because it talks about changing IP addresses. It obviously stands for network address translation. But what is NAT and how does it work? For those of you in the chat room asking about what's on the Network Plus test, I'm going to get to that in just a bit. I've got a whole section on that, so stay tuned. Network address translation is kind of like it sounds. I have an IP address coming through a device. Usually it's a router or it's a firewall. It's something working at layer 3 because we're talking about IP addresses here. So it's coming through and I want to change an address before I send it on its way. I want to take information coming into that router and it says it's going somewhere, but I'm going to change the IP address so it goes somewhere else. Why would I do that? Why would you ever need to do network address translation? Well, generally, there's two different kinds of network address translation. You're probably doing one of them on your home network. If you have a router connected to your internet connection, it's probably doing this. It's probably doing a source network address translation. And you can see in here that I have, for instance, you've got all of these IP addresses that are inside of your network, 192.168 addresses. These are internal addresses. These are addresses on the 10 dot addresses, the 172.16s, the 192.168s. Those addresses will not be routed by any device on the internet. If you were to send that IP address out to your ISP's router, it would drop it. Wouldn't even send it. Does not even go anywhere. Well, that's a problem. Because I built all these IP addresses inside of my network with 192.168, and now you're telling me I can't even send it anywhere. How am I supposed to talk to Google? Well, what we do is we use our router that's going out to the internet, and we tell our router, if you see anything talking out to the internet, change the source. Change if somebody's going from 192.168.3.22, change its source address to 66.20.1.12. So it looks like it's coming from 66.20.1.12 and it sends it out. And that way it's routable. It goes anywhere you want. It goes all over the internet. And when it comes back to 6620, you've asked for your Google request, your Google page comes back to 6621.12. Your router remembers, oh, wait a second, that request that went to Google on that port number really came from 192.168.3.22. It converts that source address back on the inside and sends it to its original space. So as you can imagine, you have this big table now inside of your router that is your network address translation table, and it's keeping track of all of these translations that are occurring in real time. It's keeping track of all the sessions that are open and what's going on. It's a lot of work going on with that network address translation, but having that functionality, having that big table, having the router handle that translation piece means that we can have as many machines as we want on this side of the router. It takes up 0 IP addresses from the rest of the world, from the big list of IP addresses that we could possibly use. So very useful to have that translation process occur at OSI Layer 3. The question that Gloria asks is, what protocol is being used for that NATing? Well, there's no specific protocol that's being used to do the NAT. The device itself inside of the router is the thing NATing. And it just recognizes, in fact, it probably has a policy inside of it that says, if anybody ever talks out to the internet, and usually it's over any protocol, any port number that's going out, translate this IP address or it's not going to be able to go anywhere. And off it goes. Very, very simple to make that happen. On that piece. So one of the questions that came through is what about these automatic IP addressing that occurs? If you didn't give an IP address, you don't have a device, a DHCP server, you've not assigned, you get an automatic address, are those routable? And I guess that really depends on the router or the NATing device that you have. The address itself is not routable, but if you can NAT it to a routable address, then you're in good shape. So in some cases, you can absolutely do that. In some cases, you don't have that functionality to NAT within. You wouldn't be NATing inside of your company. This is a NATing outside of your company. And in that case, you wouldn't be able to route anywhere else inside of your company to communicate back and forth. So very useful to have that there. Now, what about NATing the other direction? Why would you ever want to NAT inbound? Well, this is a case where there's people out on the internet with their own external addresses. Heck, maybe they're being NATed out on their side. We don't know. But they're coming into us and they're communicating to 66.20.1.14 because that's all they know that is our public IP address. That's the IP address we stuck in our DNS server. That's how they know to get to you. And let's say they want to talk to our web server over port 80. So as this is coming in, we recognize, oh, you'd like to talk to 66.20.1.14. Oh, and I can also see that you're using port 80 as the destination where this is going. That's my web server. I have a policy set inside of my router or inside of my firewall that says if you ever talk to 66.20.1.14 and you're talking over port 80, I'm going to always convert that to 192.168.3.22. And I'm going to send it on its way because that's my web server. And of course, it builds a table. On the way back, it reverses that and sends it back out to the internet. Same thing we just saw, except in the other direction. And you can see also there's another policy that says if anybody talks to 66.20.1.14 and they're talking to port 25, they're trying to send mail to me. They're trying to send SMTP traffic to me. Translate that one, but don't send it up to my web server. It would have no idea what to do with that. Instead, send that traffic to 192.168.1.3. It sends it down to another device that is my mail server. So we're actually translating the address of where it is going and sending it on its way. In those particular cases, and you're right, that is a port forwarding, Carlos. We are port forwarding this. We're forwarding the traffic based on the port and also doing a network translation. So really two things are going on at the same time to some degree like that. Corberg asks in the chat room, does NAT ever fail? And how would you know? Let's say that you had so much traffic going through that your NAT table got completely full. And this does happen on very, very old legacy systems that have a limited NAT table. They could fill up the table. They can't fit any more in. And so they just drop the packets. You would know because you would not be able to talk to Google. You would suddenly have people say, I can't talk to Google. What's going on? And usually inside of your firewall, inside of your router, you can see exactly how many entries are in that table. It will tell you, and it will even probably have another log there that shows that you're dropping traffic. And usually it has a description of why you dropped that traffic. Can't go through. My table's full. Sorry, done. Drops it on the floor. So you may run into connectivity problems if your natting is not working. One of the other questions I got from folks coming through is one of these. So this was, a lot of people asked me questions about IPv6 on what we were working with. IPv6. Let me bring this up so you can see it. So I thought an IPv6 question that they asked me would be a good one to ask you. In IPv6, which characters can be used to abbreviate the groups of zeros that you might have within an IPv6 address? It's a good question, I think, because you've got, in this particular example, a pair of asterisks, a pair of dots, periods, a pair of colons, and a pair of @ signs. So we know at least it's a pair of something here. And we've got 19 results in. So the real question, a lot of people say, I'm really worried about IPv6. It looks kind of complicated. It's hard for me to understand. Is this something I should really be concerned about? Let's find out. You guys shouldn't be concerned at all. 91% of you says, yeah, use the colons. Yeah, double colons will abbreviate groups of zeros in IPv6. IPv6 is not really that difficult when you start looking at it, you start working with it. Granted, it's much bigger. It uses hexadecimal. Don't let it throw you. It's just an address, just like any other that you might use. It's a little bit longer, certainly. A lot more there. But the basic functionality of layer 3 communication works exactly the same whether you are using IPv6 or IPv4 or IPX. You're communicating at layer 3 to be able to do that. So very useful. Very useful to have that there. The next section of questions I'm going to go through, we're really got an extended version of our Network Plus study group this week. The next section I'm going to go through are a lot of the questions that you guys already asked about what should I expect on my Network Plus exam? Do I take the old exam or the new exam? How should I know what I should study for? We're about to go through all of those things. But before we do, I wanted to send my appreciation and thanks to GTS Learning. They're the ones that are sponsoring me being here live and talking for an hour and 17 minutes at this point, because they have a brand new product they showed me back in November when they were working on it. And I got very excited about this. Something called Freestyle. And we were talking because they use my videos a lot in some of their books. And they said, you know, we have people that are asking us for our books, and we have people that are asking for test exams, sample exams that they can go through. We have people that are asking for videos. We want to be able to provide all of those, but provide it in a way that makes it very easy to use. We don't just want to send a book, and we don't want to send videos, and we just don't want to send them questions, because it's hard to blend all of those things together. And with Freestyle, they've done this. They've taken every single one of these things and blended them together. This is my Freestyle page. I probably am logged out at this point. Let me go back to my home screen. Let me show you what they've done here. I'm going to put in my password, my username and password here at the top very quickly with my LastPass. Thank you, LastPass. So here is, I've got a bunch of their courses in here, and I'm going to punch the N10005 that they have. What they've done is take the entire book that they have, and they've put it online, every word for me to read. They've taken all of their sample exams and put them in exams they can use. They've taken all of my videos and integrated it in directly with the text. So now you've got this course that you can go to, and let's say Unit 1, which is topologies in the OSI model. Here's the study notes right here. This is what you would normally read as if you were going to be reading the book. It's right here. In fact, there's links where you can go to other parts of this book and read those pieces too. The diagrams are in there. And in some cases where you get down to trying to understand more about the actual technology itself, my videos are in here too. We blended in all of these pieces that you would normally expect to see right into the study notes. So you can go through here at your own pace. It's always available online for you to read. And if you get to a point where you're trying to understand more about it, my videos are right inside of what we're looking at. So that makes it very simple. You can easily say, oh, well, I'm in the OSI model section. I've just read about it. What else should I know about that piece? And I've got
the OSI model stands for the Open Systems Interconnection Reference Model.
And it's a way to help us I think we've seen something like that before, haven't we? And once you're finished going through those pieces and stepping through all of those, they have, with the study notes, they have review questions for each one of the sections. Here's review questions for the OSI model. Let's go take a quiz right now. So first question that comes up, what happens at the network layer if the router cannot transmit a data packet as large as the one received from the source computer? And this one happens to be one where I have to actually type in the answer and have it work on that. Let's see if I go to the next one. Well, like the next one, what term is used to describe a topology in which computers act as both clients and servers? So it's all in here in this freestyle that they've got set up. Very, very interesting scenario that they've built. I highly recommend you go look at it. If you buy their books today, you also get freestyle thrown in for free, which I think is a great deal. You can learn more about this at professormesser.com/freestyle. And again, we really appreciate what they've done at GTS Learning to help sponsor what we do here at Professor Messer. So let's also now move ahead to some of the questions you guys have about the questions. So I put a new section in here for the CompTIA Network Plus questions, where we should be able to do this piece, to have this here. So this is one of the questions that has come in. Mike sent this in earlier, which is, how many questions are on the test, and what is the time limit for the Network Plus certification? And for some of you who are now, the vast majority of who are on this call are listening to this, you're on your first or third month of going through this piece. I highly recommend you go out to the CompTIA website and look at this. They have a whole section. In fact, let's just do that right now. Let's go out and go to CompTIA.org. And I'm going to move my screen so you can see it. There we go. Out on the CompTIA website, there's a section right at the top for certifications. And if we go down to Network Plus, you will be able to get the qualification of exactly how this works. Even tells you the old one's available through August 31st, and there's the details. So I don't make the CompTIA exams. I'm not associated with CompTIA. I'm not a CompTIA member. I don't want to be. I want to be very independent with CompTIA. I know exactly what you know. In fact, when new versions of the test come out, you guys are usually telling me first, hey, they're online, they're ready to download. I'm like, oh, good, let me go get them. You're telling me about it. I have no way to know what's going on the CompTIA unless I call them, just like you do. So right there tells you there are 100 questions. It's 90 minutes long. The passing score is 720 on a scale from 100 to 900. What the heck is that? Why do they have it set up that way? What does that even mean? Is that a percentage? Is it not? It's not. Don't be fooled by that. Don't be thrown by that either. Every test exam question that you get has a different number of points associated with it. And you never know what questions are worth more points. Generally, I believe the easier questions are worth fewer points. The harder questions are worth more. Maybe it's vice versa. Maybe it's worth different if you answer than if you get it wrong. I don't know. It's a mystery. We don't know. All we know is that ultimately the score you need to get is a 720 between 100 and 900. The best possible score you can get is 900. The worst possible score you can get is 100. I guess putting your name on the exam gives you 100 points. I'm not sure. So something like that. The experience they give you, it's in English and Japanese, and there's the exam code you would see associated with that. Yeah, 100 points for free, Renee. That's fantastic, isn't it? So some nice capabilities there. The CompTIA website at CompTIA.org is the one that is detailing all of those pieces. So that's where you would find all of those for yours. And some of the questions that are coming in is very, very valid. And we're going to talk about some of those as well with your what's on the exam and that type of thing. One of the other questions that's even come up in the chat room is, how long should you study before you take the Network Plus exam? Paul asked that. There was also the question of, how would I even know what to study? Now, obviously, the Network Plus exam is one of the most well-known certifications that are out there. Many of the CompTIA exams are ones that people know about. But the real challenge is knowing when you should book your exam and be able to take that test. And if you go out back to the CompTIA website, CompTIA is so good about this. They give you a very, very, very detailed overview of exactly what you should know on the exam. The exam syllabus, the exam requirements document that they have has a ton of information on it. And that exam requirements will take you through everything you'd possibly want to know. This is the first page, in fact, up here. Compare the layers of the OSI and TCP models. Let me move my head so you can see this. Layer 1 physical, layer 2 data link, layer 3 network transport. There's the TCP IP model and what you need to know. Classify how applications, devices, and protocols relate to this. They give you detailed view. This is just the very first couple of sections of the exam. So tons of data to get out of the exam objectives. I recommend that you print them out and use them as a checklist. And if you can check off most of what's on here, you're ready to take the exam. It's a great sanity check for you to know if you're really ready to take the A+ certification or the Network Plus or the Security Plus or any of CompTIA's exams, because they give you such detailed, rich information. If you go out to Microsoft, take a Microsoft exam, you don't get this level of detail. It's remarkable what they've done here to be able to provide you. And they really do stay very, very close to exactly what's on here. They don't really go outside the lines very much. So it's a very specific set of requirements, and it's extremely comprehensive. So take advantage of that and know that it's there. One of the questions that just came up in the chat room applies to one that we just saw, which are there questions that are not multiple choice? Randy asked this, and in the chat room earlier, somebody was asking for the questions. What are these questions? Are they graphics? Are they fill in the blank? Are they multiple choice? Today on the Network Plus exam, for most of what I have seen, the multiple choice links are what you get in all of the Network Plus. Now, I've seen some people at CompTIA and other places have told me there may be a move to do different kinds of questions later on. But today on Network Plus, last I heard, everything is multiple choice. I know when we saw the freestyle stuff that was out there, the freestyle was one that gave you fill in the blanks. It was just trying to get you to understand more about it. And again, you find that link at professormesser.com/freestyle to be able to see that. So there's quite a bit you can see of those pieces. It's quite a bit that's there, but everything multiple choice. Now the A+ exam, for those of you that are also studying for A+, know that there is a new A+ exam that's coming out later in the year. There are rumors that it may not all be multiple choice at that time. So we'll deal with that whenever we get there. So it makes sense to look at that whenever those come through. Speaking of A+, one of the questions that came in was how much Network Plus content is covered when studying A+. And if you look at the exam requirements document for A+, and you compare that to the exam requirements document for Network Plus, very different. There's very little Network Plus overlap on the A+ exam. So if you've gotten your A+ or you're studying A+, what you're going to find is the Network Plus is an entirely different exam. And it's got a lot more detail and a lot more information you're going to need to know. And one of the questions in the chat room from Gloria is, should you have your A+ before your Network Plus? CompTIA suggests that you do have your A+ first, then take your Network Plus, then take your Security Plus if that's the path that you're going to follow. The thing that you run into, or that I ran into, is I did it backwards. I got my Security Plus first, then I got my Network Plus, then I got my A+. But that's because that happened to be where I was in my career, and what I was doing is that it really pushed me to take my Security Plus first. So it was one of those times where I did it the wrong way. But it's sometimes you run into that. Sometimes you take whatever makes sense for what you're doing. Some people never take the A+. They focus on networking. They jump right into Network Plus. So it really depends on what you're planning to do, where you are in your career, and what you think is going to be best for you to either move up in your existing organization or perhaps go outside and get a different kind of job in that piece. So you'll run into those as well. Question in the chat room is, what certs hold more value, Microsoft or CompTIA? I guess that depends on what you want to do. And I get these questions a lot about which one of these is really going to be the best. Is it going to be a Microsoft exam? Should I take a Cisco exam? Should I take one of the security exams? Maybe the ISC squared has some good security exams. Maybe the Certified Ethical Hacker. Do I take some other type of exam that's out there? And it's hard for me to answer that question because it depends on what you're doing, and probably more importantly, depends on what interests you the most. Are you interested in going into security? Are you interested in doing project management? Are you interested in data center administration of servers? Are you interested in networking with routers and switches? Really focus. That's where you need to focus, is go there and be able to do that piece, to be able to have that access of what you're trying to do. I think that's the most important part. Do what you think interests you. And if you have no idea, you're just getting into the industry, take the A+. And then once you finish the A+, you've now had a little bit of computers, you've had a little bit of networking, you've had a little bit of security. You'll probably get a job where you do a little bit of all of those. You're going to figure out pretty quick where your interests are. You're going to figure out, I'd like to do databases. I'd like to work on servers. I'd like to do networking. I'd like to do security. You'll know. And you'll be able to follow that lead to be able to do that piece. One of the questions in the chat room is, are all of the CompTIA exams, do they all have to be renewed after a set of years? And the answer is yes. For the A+, the Network Plus, and the Security Plus, you have to renew them every 3 years. And the renewal is one where you would accumulate continuing education units so that you don't have to take the exams again. You would take a more advanced exam, which will automatically renew your old exam. So if you took the A+ and you took it last year, and then you take the Network Plus and take it again, it renews your A+. If you then take the Security Plus, it renews both your Network Plus and your A+. That's a very easy way to keep things renewed, isn't it? Can you take the exam again? That's your last choice, actually. Let's say 3 years goes by, you didn't continuing education units, you didn't provide any of those, you didn't take any other certification exams. Your only choice at that point is to take the exam again and have that go through. So that's another option that you have available to you, to have that piece in there as well. And it's one of these things that is an international requirement to be able to have exams renewed every 3 years. It's very important. There's a big story there that we can talk about probably next time we go through why we have to do exams every 3 years. And it's hard to find an exam these days from anybody that is permanent. Microsoft tends to have permanent ones because they're on particular subject matters. But for things that are more broad, like A+, Network Plus, Security Plus, absolutely 3 years. A lot of the security exams that are out there in the world are 3-year exams, those types of things. I've got a few other questions that came through on some other pieces. Oh, and the question in the chat room, which is a good question, Addy Geo, which is, I'm going to take a Cisco exam. Will renewing or getting my CCNA renew my Network Plus? Will take a Microsoft exam. Will that renew my CompTIA certification? It will. How about that? So there's something you probably weren't expecting. If you take a Cisco, it renews your CompTIA exams. If you take Microsoft, it renews your CompTIA exams. So if you go out to the CompTIA website, in the renewal frequently asked questions document, they tell you exactly which Cisco and which Microsoft exams also renew CompTIA exams. How about that for a shocker? That's one that you weren't expecting, was it? And that's absolutely the case. So often you never even have to worry about this 3-year thing, because you know in the next 3 years you're going to get another certification. You'll just have it renew when you do that. So very, very simple. There's no reason some of you guys should even have to worry about that piece. You're just going to keep taking those certifications and keep renewing those pieces. Gloria asks in the chat room, when you're looking for a job, what do you think people are really looking for out in the IT world? And this is one of those things that I get multiple questions a week on this. Hey, I saw your website. I'm going to take my A+ certification exam. How much am I going to make? What job am I going to have? Tell me. Tell me what I'm going to make. The certification is one aspect of what you're going to bring to the table when you're interviewing for a position with a company. Now, generally, an A+ certification, you're interviewing and you're getting perhaps an entry-level position in a help desk or a hardware repair type facility. If you do networking, the networking piece also handles that piece. So for networking, you would also have situations where you might get your Network Plus exam, but it doesn't guarantee that you're going to get a job. Just because you have a ton of certifications doesn't guarantee you anything, but it certainly makes you more attractive to an employer. And having interviewed and hired a number of people at a number of different levels in different companies, I think it's probably a mixture of 3 different things. I think certifications get you noticed. It gets you in the door. It gets you the interview. If you have an A+ and a Network Plus, you're certainly going to be higher qualified than somebody with exactly the same experience and exactly the same educational background who doesn't have those certifications. And it gets you noticed that you are at at least understanding more about the technologies that you're interviewing for. The other thing that's going to help you is a formal education. If you have a degree, you are going to be more qualified and certainly more desirable than somebody who does not have a 2-year or a 4-year degree. A formal degree helps you quite a bit. And some people say, no, if I go get a Cisco certification, I'll get a job right now. And I'll probably get a job. I won't even need a formal degree. That may be true, actually. If somebody really, really needs a Cisco person and you have experience and you have a Cisco certification, they might overlook the fact that you don't have a formal degree. Now, what happens 3 years from now, 2 years from now, even next year, if it's a company that's really growing, what happens when they say, we need a senior tech, we need a manager for that department, we need a director for that particular networking or security department? Other people are going to be there that have formal degrees. At that point, it's going to hurt you. So not having a formal degree might not be a big deal at the moment. But if you get in an organization and you're looking to move up, and especially if you're getting an organization that actually gives you money for going to school, these are great situations. Your employer wants you to be educated too. Take advantage of those if you have the ability, because that's some very, very inexpensive way to get a college degree that I assure you will help you now for 30 years. That formal degree is going to come in handy somewhere in there. Probably so. That's something that you just have as a insurance policy, and it certainly is going to help you later on. And the third piece is some type of experience. And this is really one of the hardest things. I'm trying to get a job. I want a job. They want experience, but I don't have experience because I don't have a job. That's the common catch-22 that we always hear about. So one of the things that we go through is trying to figure out, where can I get that experience? But there's a lot of places where you can help out. If you go to church, I bet your church has computers. You can be the person that handles the maintenance on those systems, handles the networking aspect of it, make sure the antivirus is up to date, make sure the printer is cleaned out every month. If you have some organizations, volunteer organizations in your community that have computers that need somebody who's knowledgeable to keep them up to date, to do all of those things, to load software, to make sure they're networked, to make sure they're backed up. These are organizations that don't have a lot of budget. They rely on volunteer. And experience is experience. Doesn't matter whether you're getting paid for it or not. Experience is experience. The more you have, the better off you're going to be. Very, very common to see something like that. In the chat room, one of the questions that was asked is the Network Plus 004 exam still relevant now that the 005 is out? That's a very common question, a very good question to be able to do that. The 004 exam and the 005 exam are different. The 004 obviously is about 3 years old. The 005 just came out in December. When you take and pass either one of those exams, you get exactly the same certification. You take the 004, you get a Network Plus certification. You take the 005, you get a Network Plus certification. They're exactly the same. They don't even say you took the 004 or you took the 005. They are exactly the same. So it doesn't matter which one you take. Now, obviously, the 004 is only going to be available till August. And they do that so that if you've been studying all this time on the 004 information and suddenly a new one comes out, you don't have to lose all of that work that you've done. You can still take the exam, and they give you a long runway. August is a long time to study up and take the 004. Now, if you haven't taken the 004 or you haven't been studying for the 004 is really what I should say, you've just started this, I would recommend that you take the 005 because it's the newest. You're going to learn the latest technologies because things were updated in the 005. 3 years is a long time in our world, but ultimately it's exactly the same certification. The only time I would deviate from that is if you're at an organization, you're at a company, and they say, we'd like you to get Network Plus certified and we want you to get the 005. They may tell you, you have to get the latest one. Other than that, they are not looked upon as being lower than any other cert. They look exactly the same on your on the transcript. Your piece of paper looks exactly the same. There's no difference. You got a Network Plus certification. And the reality is there's little differences between those to be able to do that. Very, very, very interesting to be able to see that piece. Another question that came through. So somebody says, what about my educational background? What about my college? What about my degrees? What about my certs? I don't think that's too personal. I could probably share that. That was Rob that asked in the chat room. I got a degree in business management from Florida State University. So that had practically nothing to do with computers. While I was at Florida State, I worked in their computing center part-time. So I got some experience on mainframes, got some experience on working at a graveyard shift, working with printers and loading tapes and doing that type of thing. I got out of college, I got a job working at a computer store in South Miami. So I delivered printer cables and installed hard drives. So entry level, absolutely. At that time, there was no A+ certification. You had to be certified from Compaq. You had to be certified from IBM. You had to be certified by whoever's machines you were working on. So it was a little bit more difficult back then to get the exact certification for what you needed. From there, went to a larger insurance company that's no longer around in Miami, but it's a big one. It was gobbled up by a larger company. And got practical help desk work. And then from there, moved into the networking group. From there, started working for other network providers, and sort of the career sort of blossomed from that piece. But I started with a little bit of real hands-on experience in the computing center. I had a degree I could work with. Didn't really have any certifications, but I managed to start working at a very small computer company in Miami where I got the certifications that I needed. So as I mentioned, a little combination of those three things become very, very handy later on, obviously. So it becomes really useful to have that piece of it. What certifications do I have? Gosh, over the years, I think I added it up at one time. I laid out all the different certifications that I have. There are about 30 different ones. Practically all of them, the vast majority of them are out of date. They were like Windows NT certification, that kind of thing. And there was other old certifications people don't know about anymore, like the CNX certification in Ethernet, in Token Ring, in FDDI. Some of those are very, very old. But these days I have the CompTIA certifications, some Microsoft certifications. I have some other security certifications that are specific to certain manufacturers' equipment. Really focus on the security side of things during the day and do the Professor Messer things at the night. So nice combination of different pieces there. I say work on all three of these things. Get your certs, get some practical experience, get some formal education, and you've got a nice trio to go in and get those jobs that you want, move up in the career you want, do the things that you'd like to be able to do. Through the chat room, we are a few more coming through. My eyes themselves are glazing over at this point. Let's keep going. Oh, in Portland, Oregon, RMC Ustream says you volunteered at Free Geek. So there's a very good example of going to an organization that does things for free for other people and volunteer there for what they're doing. What a great idea to be able to get some practical experience in that piece. Addie Geo says date the boss's daughter. That's 4. That's your 4th one to worry about, or boss's son. That's their 4th one to worry about and work with those pieces. What certifications do you need for teaching with an online school is an interesting question. I don't know. I don't really teach with an online school. This is sort of my doing here. I don't have a formal school here. So I don't have students that are here. Nobody registers for classes. That's probably, I would expect, if you're teaching at an online school, you're teaching a particular subject matter. So you're teaching a Microsoft course, a Cisco course, a networking course. It probably would make sense to get the certifications that are specific for doing those types of things. Panth610 says, currently going to tech school for networking and a security diploma. Very nice. Didn't go to college. Doesn't matter. How does that affect my educational background? Well, obviously, a technical certification or a technical degree is still a 2, in some cases a 4-year degree. There's still a very powerful statement that you're making that says, I went to 2 years of school and got trained on something very specific. It probably is not as good a degree or as powerful a degree as a 4-year university or college degree. But often when you're going into these jobs, you may not even be competing against somebody who has a 4-year college or university degree, or you might be. So that's where you have to balance these things out. Maybe the person with the college degree doesn't have any experience. If you have more practical experience, you're going to have a leg up. If you've done more work with that apply to what these people are trying to do, you'll have a leg up. Let me give you an example of this. One of the things that you run into with these is you have cases where an employer is looking for a particular skill set. They may come to you and say, I need somebody who really, really, really knows networking. Or I need somebody who really, really, really knows, here's a good one, Linux. Linux skills are hard to find right now. And if you know Linux, well, there you've got a little bit of a heads up over somebody who only knows Microsoft. So sometimes you'll run into those situations. Those are rare, but they can really help you in the long run. Okay, before we finish out, I have a question for you, something that can really, really, really help me. So I'm going to pop this up on my screen as soon as I get this piece through. And you're right. This is one of these things where when we are looking at trying to figure out what to do with our career, it's more than just certifications. It's more than just trying to figure out what's happening and where these things are coming from. So I think that's one of those times where when we work with these pieces, that becomes very, very important for us. So the question I have for all of you is, what topic would you like to see on the next Network Plus study group? Which ones make the most sense for you? So I've already got a few that are coming in. Security, yep, I think security would be a good one to come through. Send your answer. You can text to 404646. You can tweet to @poll404646, or the easy way, go to pollev.com/Messer. There's another one. DNS records has come through. That's a good one to think about. Linux. I mentioned Linux, so why not have some Linux in there as well to come through that link? I agree. That would be a good one to have there. I take all of these questions you send me, I store them. I have an enormous spreadsheet with every single question I've ever been asked. I'm not kidding you. One for Network Plus, one for A+. I have a Security Plus one that I build, another one for DNS records, another one for servers, troubleshooting, port numbers, questions about more questions to the polling system. So, well, if you like the polling system, I like that kind of feedback too, to be able to see that. Subnetting. We didn't do much subnetting this time. We talked about classes, but we'll absolutely talk about subnetting next time. That's always an important one. The cabling that's there, those pieces are important too. We did a cabling one last week. If you want to go back, I think it was last month's rather, Network Plus. Go back and look at that one. We did some cabling there as well. And I just did some new cabling videos for the 005, changing firewall rules. That might be a good one to get more information about coming through. So, well, you guys got a lot of great ideas and tips for the next study group. How do you know where to start studying for CCNA? How important is it in the networking industry? You know, Cisco is a relatively important certification network-wise, of course, as long as you're going to somewhere that has Cisco equipment. Not everybody does, but obviously the vast majority of people do at this point. And you'll notice I don't have any Cisco training guides or training materials. It's not something I have on my production schedule. Maybe someday I'll be able to provide something like that, but currently I don't have plans to provide any Cisco-specific training materials at this point, although some of the people are able to take some of these network and security videos that I create and do those as well. In the chat room, you've said VLANs. That's a good one to talk about. Physical tools. Yes, that would be good. The time domain reflectometers and those types of things. Routing protocols, IGP, EGP, and those types of things. Those would be really, really good as well. X25 versus Frame Relay. X25 no longer part of the Network Plus certification, but Frame Relay absolutely is. MPLS absolutely is. We can talk about those. Gosh, here's a big one. Linux. Everybody wants Linux. I'm not gonna put that whole. Why not? We'll put that whole thing you wrote up here that talked about Ubuntu and some of the things dealing with Linux. Some of the things about GPOs and user management that have come through as a request for that are things that we don't cover in Network Plus. It's not part of the Network Plus certification. It's more of the Microsoft certifications. But the second part of that deals with VLANs and VPNs is certainly one we discussed. And we talked also a little bit about that in last month's study group as well. One thing to remember is in these Network Plus study groups, the A+ study groups, they're all recorded. So you can go out to my webpage, freenetworkplus.com. They're at the bottom. I just keep adding them on to those lists that are there. Wiring distribution would be a very good one. That's a good one, Carlos. Operating systems are not covered in the Network Plus exam. That was a question that came through with one of those polls. So that was one that we don't have to worry about operating systems. We do have to worry about how you would manage addressing in those operating systems. You guys had a lot of great questions with this and being able to work with those pieces. In fact, I can see there's so much Linux requests in both this and even the chat room. You guys are great. You've been giving ideas about using VI in the chat room and be able to work with that. I think that's fantastic. I think Linux videos would be great to do as well. So I hope to be able to manage to get some of those done soon in there. Well, with that, we have come close to the end of what we're doing. Let me remind you all again that if you want to watch what we're doing, you want to be involved in any of these live events that we do, that you can find me on Facebook at professormesser.com/Facebook. You can find me on Twitter, professormesser.com/Twitter, professormesser.com/Google+. I need to do more Google+, and professormesser.com/YouTube to go to my YouTube channel where you can see any of our videos. Somebody asked earlier, how do I get to that freestyle stuff again? Couldn't be easier. professormesser.com/freestyle will take you right over to GTS Learning, and you can find out more about what they're doing on the freestyle side. This was a big one today, almost 2 hours of these things, and it would not have been able to do this without your help, your questions that come in, the comments that you make on Facebook, the messages you send me directly. Very, very useful to have those. I sure appreciate everything you do to make this so successful that we do every month. I hope I'm able to do even more of these in the future. And with that, we've come to the end of our Network Plus study group for the month of March. Thanks again for joining us. We'll see you next time on the Professor Messer Network Plus study group. See you then.